So, my name is Daniel Miles. I'm with Oregon State University, and my senior capstone was actually working with Remy to enhance the COLLADA web viewer. My partner Michael could not make it today, unfortunately. He has just recently picked up with HP in Texas. So that's exciting, and congratulations to him. But the plane ticket and everything after getting settled in Texas from Oregon was a little much. So, what is the COLLADA web viewer? Well, just brief overview, it's a lightweight 3D modeling utility that's usable by any browser that supports HTML5 or WebGL. So it's designed to be accessible. Our big watchword for all of this project was accessibility. Was the idea that anyone should be able to use 3D, because that's where the world is headed. So even if they're just, if they're young, or if they're older and not acquainted with computers, they should be able to pick this up and use it. It doesn't require any additional downloads. It doesn't require them to do anything special. You just log onto the website and it's there. It imports any triangle-based COLLADA file and renders them to a scene in the browser window. So the question of why COLLADA? I mean, obviously because Remy sponsored the project, but beyond that, COLLADA is open source. And because it's open source, it's accessible. The idea that you can use it to share with others without worrying about proprietary software, it's already a solid transition format. If you have to translate a file between like Maya or 3D Studio Max or all these different editors, you can use COLLADA because these formats don't necessarily have to support one another's proprietary format and pay royalties. They can simply support COLLADA, which is free. So once you have, once you've found all these things share COLLADA in format, COLLADA becomes the format of sharing. And because of its small file size, it doesn't require massive uploads or downloads. COLLADA is uniquely poised to become the 3D format of the internet. Because if you can post it online as a COLLADA file, and it's half the size of a Maya file, then that's a win. So, I inherited this code, or we inherited this code. It was actually originally started last year. If some of you may remember, I believe Ryan stood just here last year by another capstone team, and they started it up using Google's O3D plugin. WebGL, as was previously mentioned, was still sort of in its infancy. It was developed using JavaScript, and it was designed to import and view a single file. So in going forward, here's what it looked like. Pretty simple, pretty straightforward. You load one file, you can look at it, you can spin it around and check it out. It was rendered in the browser, and that was really the goal for the initial run. But then WebGL hit, and suddenly we could use the graphics card to access all the from the web browser without using the O3D plugin. So unfortunately, it was somebody made the remark that it was really discouraging at the end of that project because all the work they put in, and suddenly it was in large part irrelevant, but it wasn't, because it really functioned as a proof of concept for our development. So when we came along and attacked this project, now that with WebGL in the picture, and as was mentioned, it's running faster, it's running better, and as the technology matured as we were working with it, we found out that there were a lot of different things we could pursue. We went ahead and we looked at their old O3D code, and Google did provide basic conversion directions to convert their code, convert old plugin code to WebGL. And so we started with that and got a brief format here running, just a prototype of how it works on WebGL. And that worked out pretty well. There were still some problems with rendering. Our shader actually was our biggest problem converting it to WebGL. We found that the shader didn't interact quite the same at all. We consulted with somebody who knew the language a lot better than we did at the time, and got things working. So, but beyond that, we also took the 1600-line JavaScript file that we were handed, and we broke it out using Dojo to a legible file hierarchy. So different files that manage different functions that included different, we basically broke it down into a class structure, allowing this program to be much more readable, much more maintainable. And we also took the opportunity to modulize the back end. So we're still using O3D, And I talked to a Google representative here at this conference, and he promised me that they would think about having a vote about maybe going back to supporting O3D once WebGL had its legs under it. So on the off chance that O3D, goes the way of the dinosaur, you can go ahead and just implement a new backend to this whole process. We can develop support for coprolift, we can develop support for all these other processes without having to go back to the drawing board. And it would just be a simple matter of putting something else into this wrapper that we've developed. We also, as I mentioned, refined the shader code to play nicely with WebGL. And we've adapted a lot of the interface, and as well as the way it parses the XML, in order to allow us to look forward into editing features. So as we move forward from a basic viewing program that we loaded one model at a time, we changed the way the camera controls work to allow looking at it as a scene rather than a single model. And we also broadened the XML tree and the number of objects that can be handled by the program to incorporate multiple models into this scene. And so this is sort of what the UI looks like right now. And as you can see, we have a drop down and an add to scene button. And adding the companion cube to anything that makes it cooler. So we got a lot of attention at the Senior Capstone Expo at Oregon State because simply we had the companion cube there. We drew people in. But the rotate scene and rotate camera the rotate scene is a lot of that rotates it around the origin view that a single model uses. Whereas rotate camera is a far more like first-person style camera to look around the scene. So it's these kind of changes that were required as you look toward an editing perspective, toward creating a scene, as opposed to simply viewing one model. So as we move forward, the next steps involved in this project are going to be adding more editing features. Unfortunately, as a proof of concept, the features that we inherited were slightly limited. I mentioned it was triangle-based models only, so we're looking at increasing the COLLADA schema support. We're also looking at adding matrix transformation into the code to allow us to rotate and resize the models, as well as matrix translation to shift models off of the origin where they're currently stuck. So these are actually relatively low impact changes to the code. The big problem we struggle with here is changing the interface to reflect these changes, to give the user access to these formats. We're going to need to implement mouse pointer collision, and we're also looking at adding a list of the components currently involved in the scene that is selectable in that interface. So if you look back at this interface down in the white space here, we'll be adding a tree of components in the scene that you can select and don't have to worry about mouse collision. In the final version, we hope to have both options available so that the user can use whatever comes most naturally to them. Wow, that didn't come at all. What I have pictured there is actually two models on the scene. We used we have a very simple blue cube that was initially used in our first runs because it has no textures at all. And the other model on there is the rock star of this whole project, the tiny rocketeer, which was actually designed by the artist consultant that the first team used. So, are there any questions about the COLLADA web viewer and what it is and where it's going?
So, I'm interested to know what was your knowledge, your experience and knowledge before you started the project? How long you worked on the project, and what's your the technology you used and did how far would you have gone with that, let's say with that, if you didn't have that or you have O3D, was that in a way because you had a lot to learn and then or did that help you to manipulate and display objects?
When I started this project, I actually didn't have a lot of experience with most of the tools that were involved. I was new to JavaScript. I was new to COLLADA. I was new to O3D. And so it was a lot to take in at the beginning. But I do think that having the O3D code, I worked on it for about 9 months, along with my teammate, clearly. And having the O3D code, having that proof of concept, allowed a touch point. So it was a very solid, reference point of, okay, they did this. How do we want to tackle this problem? We're looking at using slightly different protocols, but really having that code as a basis is, like I said before, a proof of concept was extremely helpful. And so the biggest problem was coming up to speed on all the tools that were involved, but I think that having come up to speed on the code that I inherited as well wasn't a detriment at all.
Well, I have to say I use this opportunity to provide a task student with those type of projects, because it's very interesting to be able to monitor how long it takes for a student, a new domain to use technology that comes out. And WebGL is, red hot out of press. It's just really new. There's no books yet, I think, on it. And,
it was really exciting to work with WebGL because up until about halfway through the development period, we were using Minefield and really ran, shaky versions of browsers. And in the end, Chrome was the first one to come out with WebGL support, and which was actually fortuitous because the JavaScript debugger on Chrome was a godsend. We ended up using that so much.
So it's very impressive, and it's sometimes very nice that it is actually possible to use brand new technology and do something, realize the project in a short amount of time and be successful. I think it's very impressive how much the free technology and its availability has progressed within the last 10 years. It would take many years to be able to organize new technology for somebody new to be able to put a cube on the screen.
Absolutely, and that's what makes this so exciting, is the fact that it's all open source, it's all free. It's really, like I said, it's COLLADA is poised to be the free format of the internet. It seems to be designed for sharing. That is, everything about it lends itself to that paradigm.
Okay, well, thank you very much.